All right, so hopefully this microphone is working. It's been a while since we've done a video. Let me turn up the gain. There it is. All right, so been a while since we've done a video. Hopefully this mic is now working. I left my headset at home. But today we're going to be talking about the law of sines. So the law of sines, as you might imagine, has to do with the trig operation sine. So the law of sines. And this has to do with triangles, like most trig operations do. And the cool thing about law of sines is it's one of the first things we get to learn that works with just any old triangle. It doesn't have to be a right triangle. So here's my generic-looking triangle, not necessarily right. Again, this does work with right triangles, but it doesn't have to be a right triangle, and that's kind of the beauty here. So the idea is if you have, let's call the angles capital letters, so angle A is what I'm referring to here, angle B and angle C, then if those are angle A, B, and C, then the opposite across from them is going to be side C. Let's do that in a different color, maybe purplish pink, so C. And again, across from each other here, this angle opens up into this side, and this angle A opens up into this side. Let's use lowercase a little bit easier to tell apart from capital A and lowercase a versus the C's. Capital B opens up into little b, which again is referring to the sides. So again, the tiny letters refer to the sides, and the uppercase letters refer to the angles. So here's the idea. The idea is that if you take the sine of one of these angles, like, I don't know, angle A, and you put the opposite side, I'm losing my markers here, the opposite side, which for angle A is little a, they will be proportional to the sine of any other angle. So in this case, let's use B, over its opposite side, which again, here's angle B, it opens up into side B. And that'll be proportional to sine of C over C. So again, order doesn't matter, they're all equivalent. By the transitive property, you know that sine of angle A over A is going to be proportional to sine of angle C over C. You can cut out the middleman here. And this is going to be true for any triangle. So the angle that opens up into the opposite side will be proportional to any other angle in the triangle that opens up into its opposite side. So what does this mean in practice? Well, if we have generic triangle, here's my generic triangle for this one. I suppose that looks a little more suspiciously right. But it works for any, including right triangles. So if we have something like this, like if we say that this angle is, I don't know, 78 degrees, and maybe that this angle is 60 degrees, and then these sides, let's call them, I don't know, X, and let's say this side is 6. So the idea is that you can solve for this side using the law of sines proportionality. So we can't use Pythag because it's not a right triangle, given the angles that were given. And we're already missing a side. So even if it was a right triangle, unless this side was the same as this side or these sides are matching, we couldn't use Pythag. So the only thing we can do is use law of sines. So what we're going to do is we're going to take sine of an angle, like 60, and that is going to be over the opposite side. Well, 60 degrees opens up into side X. So side X is going to go under here, and that is going to be proportional, right? These things are going to divide, and they're going to be equal to the division, the proportion, given by another angle in its side. So since we are given two angles and two sides that are associated, we did 60 and X for the first, we can do 78 and 6 for the other. Again, don't just assume that you use whatever angles are given to you. They could have given us this angle and not the 78. In that case, we'd have to do some math, right? We know the interior angles of the triangle add up to 180, and we'd have to figure out what this angle is, because that's the angle that's going to be associated with the side we know, and there's no way to figure out this side if we don't know that. So 78 is going to go here, and 6 is going to go on the bottom, again, because they are across from each other. I cannot emphasize that enough. When there are mistakes being made, those are the mistakes that are made. So don't make them. All right, so now we're here. And yes, I could write this for this angle and this side, but I don't have any information, so I'm not going to fill out this little portion. Typically, when we do these problems, we only use two of them. And so what we're going to do is we're going to try to get x on its own. Now, you might remember from earlier in the year, when x is on the bottom, it makes the solving of these proportions kind of difficult, and we do not cross multiply in here. So what we're going to do is we're going to flip both sides. We're going to reciprocate both sides. And again, as long as you do it to both sides, it's fine, right? That's algebra. We talk about this all the time. If you do it to just one side, that's not okay. But if you do it to both, it's always fine. And to prove that to you, I'll show it to you with numbers. I think we can all agree that 6 over 2 is equal to 3 over 1, right? 6 divided by 2 is 3. 3 divided by 1 is 3. They are equivalent. And when I reciprocate both, again, I do it to both sides, I also get a true statement. It's a different statement, but it's still true. So I have 2 over 6 equals 1/3, and we do know that 2 over 6 reduces to 1/3. So it checks out. They're both true even after reciprocating, which means I should be able to do it with anything, even weird numbers like sine of 60 and sine of 78. So we're going to flip both sides, and you could probably do this as a first step. Just write it like this instead of flipping automatically. Getting that x on top is useful. So now the signs are on the bottom, and the side lengths are on the top, which means x is on the top, which is what we wanted. And now we need to get x on its own. So if this was instead of being x over sine of 60, and instead of that being sine of 60 here, we had a number like, I don't know, 2. X over 2, you'd know how to solve, right? You'd get rid of the divides by 2, and we do that by multiplication. So we'd multiply by 2 to both sides, yada, yada, yada. The 2 would go away. We'd have x on its own, and whatever we got over here would be our answer. So the problem is that it's not 2. It's sine of 60. But sine of 60 is just some number. It's just some decimal, and we'll talk about what it is later. Maybe you already know it, but it's just going to be some number. So similar to the number 2, we're going to multiply to move it over, to get it away from the x, right? It's just some number, so we're going to multiply that to both sides. Again, do it to both sides. That's algebra. Anything else is not okay. So I do times sine of 60 to this side, and I do times sine of 60 to this side. And again, these things cancel because sine of 60 divided by sine of 60 is 1, and x divided by 1 is just x. So we're left with just x, and that's why we did it. So if you didn't get x by trying to move that over, you'd be in trouble. All right, so now we have 6 over the sine of 78 times the sine of 60. Well, these are both multiplication, so I'm going to put those together. We've got 6, and then I'll stick with our black theme here, sine of 60. And that's going to be over the sine of 78. So again, just to recap, I moved that sine of 60 over by multiplying because it was being division over here. And to cancel division, I have to multiply. So it cancels here. I get x. That's good. I wanted x on its own. I'm solving for x. And now I multiply these together. Well, 6 times sine of 60 is 6 sine of 60. That's as good as we can get it. And that's all going to be divided by sine of 78. Remember, multiplication and division you can do in any order you want. So I multiplied first, and then I divided second. And that's as close as I can get it. So good news, bad news time. If we didn't know the sine of 60, we would be done. This is as good as we can get without a calculator. These signs do not cancel. That's another common mistake. But the bad news is, and kind of the good news as well, we do know the sine of 60, so we can simplify that. We do not know the sine of 78. So if you will recall, in order to do the sine of 60, or any of the other special angles that we know, like 30 and 45, you need to draw yourself a reference triangle, or, just recall it. So we've got two triangles. I'm going to say that the angles here are 30 and 60, so we have a 60, 30, 90 right triangle. That's one of our special right triangles. And we also have 45, 45, 90 right triangles. Well, you should know from learning earlier basic trig that whenever the hypotenuse is 1, and this is only true in a 30, 60, 90 with a hypotenuse of 1, whenever the hypotenuse is 1, the opposite of 30, so here's 30, it opens up into this side, the opposite side is going to be length 1/2, 1/2. So this is 1 and this is a half. And that's all you really have to remember. You can solve for this last side using Pythag, or you could remember it. I remember that it's root 3 over 2. If you didn't remember that, call that side x, set up Pythag, solve for it. You'll get root 3 in the actual video. There I am. All right, so, and I'm back. So root 3 over 2 is going to be that side. Well, for the 45s, you'll notice, are going to be an isosceles triangle because the angles are equal. So this side and this side are also going to be congruent. So when the hypotenuse is 1, you can call them both x. Set up Pythag, yada, 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 and you get root 2 over 2. So you can remember this, or you can solve it. You should be able to do both. So these are our reference triangles, and they're really useful because when we see something like the sine of 60, we don't have to run for a calculator. We can just remember our reference triangles. Sine is SO out of the SOHCAHTOA, right? And remember, SO means sine is opposite over hypotenuse. So we look at our triangle that has a 60 degree, right? Because that's what we're looking at here, sine of 60. And here's 60. So the sine is going to be the opposite over the hypotenuse. Well, the opposite side from 60 is root 3 over 2. So the sine of 60 is going to equal root 3 over 2, but then we have to divide it by the hypotenuse. Well, luckily, our reference triangle has a hypotenuse of 1. It makes the math really easy. That's why we choose that. And so when we divide this number by 1, well, it's not a big deal. It's just a number divided by 1. And any number divided by 1 is just itself. So it's root 3 over 2. So sine of 60 is root 3 over 2. So I can rewrite this statement as 6 times root 3 over 2 over sine of 78. Remember, sine of 78 I cannot simplify. I don't have a special 78-degree triangle. That's a calculator problem, so I'm not concerned with that. But I can simplify this fraction being multiplied by this whole number. So we have 6 times root 3 divided by 2. And again, we can divide or multiply first. We just have to do both. So instead of timesing by root 3 first, I'm going to divide by 2. And you know that 6 divided by 2 is 3. And then I'm going to multiply by root 3. And what I get is 3 root 3, because that's 3 times root 3. So I did 6 divided by 2 and got 3. And then I multiplied that number by root 3 and got 3 root 3. And then over here I have sine of 78. And that's going to be your answer. That's as good as we can get without a calculator. That's all it's going to be. So the answer is that x, this length right here, is whatever 3 root 3 over the sine of 78 is in our calculator. If you really wanted to know, you could plug that in. I'm not overly concerned. It would come out as a decimal. But the idea is that it's okay to have these weird looking things here, just like it's okay to have irrational numbers like root 3 show up. They go on forever. They've got, maybe sine of 78 repeats. I'm not sure off the top of my head, but I doubt it. I believe it's an irrational number. Why round? Why write the decimal when you could just write the more correct answer? It's not going to have to round anywhere. It's just going to be it. So in this case, x would be 3 root 3 over sine of 78. So to break down what we did, the law of sines is angles and their opposite sides. And it breaks down to where the angle over the opposite side is going to be equal to the angle over its opposite side equals the angle over its opposite side. And we can use this fact to solve for missing lengths and angles in triangles. Not just right triangles, but any triangle. So this is pretty dope. Again, the 60 and the x go together because they are across from each other, and the 78 and the 6 go together. Then we do some math. Flipping up to get x is a good idea. And we move stuff around until x is on its own. We simplify as much as we can, and we call it a day. And that's how you solve for x. Sometimes the numbers come out nicely. Sometimes they don't, kind of like this guy right here. The good news is when they don't come out nicely, like if this was sine of 50 instead of 60, is that you're done. There's no more work that can be done here. When you know one of them, it's kind of nice, but it's also kind of a bummer. It takes a little bit more work. So what else can the law of sines be used for? I mentioned that we can find side lengths. But what if x was here instead of there? We can also solve for the angle given two sides in another angle. So let's experiment with that. So here's my generic looking triangle. Again, this works for all triangles, including right triangles. And I will say that x is going to be here. And it is this angle measure, so x degrees. And maybe this side is 7, and perhaps this side is 4. And they give me that this angle up here is, I don't know, how about 45? So they give me that angle is 45. Now, if they gave me that, I'd be kind of stuck, right? Because I'm supposed to have x and 7 go together, and whatever this angle is, and 4 go together. I can't solve for whatever this angle is right here. There are ways to do it, and it gets kind of messy. But in general, when this is given to you, you're missing that angle here, so you need to figure out what that is. So I'm going to give that to you instead. So if that's 45, let's call this one a 30, just for fun. The point I'm trying to make here is that don't just assume that the angles they give you are the angles you need. This 45 goes with this side. We have no information here. So that's not how we want to set it up. We want to set it up with these two and these two associated. All right, so we're going to take the sine of x, because that is our angle this time, sine of an angle. And that's going to be over its opposite side, which is 7. And again, writing sine on top works because x is on top and I want it on top. If it needed to be, if x was on the bottom, I'd flip them both up. But in this case, it starts out nicely. And we have sine of 30 degrees, and that is associated with 4. So they are proportional. All right, so from here, we can solve and get x on its own. Well, we know how to get rid of the divides by 7, and again, to make the world a better place, getting rid of division is always a good idea. That's always the first step. So we're going to multiply both sides by 7. And what that's going to do is 7 divided by 7 makes 1, and sine of x divided by 1 as well. It's just sine of x. So we didn't get rid of the sine. We'll get rid of that next. We did get rid of the 7. The 7 is now over here multiplying with the sine of 30. So we have 7 sine of 30, but it's still being divided by 4. Okay. So now, again, we want to keep getting x on its own. All over here we don't care about right now. We just got to get rid of that sign. And just like any operation, addition is inversed by minusing, subtracting. They cancel each other, right? Plus 3 and minus 3 get you back to 0. Multiplication and division are inverses. Square roots and squares are inverses. Turns out sine and sine inverse are inverses. They didn't really have any clever names for this one. They just called it sine inverse. And inverse means to undo. So to undo sine, we need sine inverse. And we're going to do it to both sides. So if I do sine inverse to this side and sine inverse to this side, what we end up with is these two canceling, right? Because sine inverse and sine cancel, that's what they do, just like division and multiplication from earlier. And we get x all on its own, so this is really useful. And then we get the sine inverse of that entire side. So all of that, 7 sine of 30 degrees over 4 is all going to be inside sine of inverses brackets. So we're doing sine of inverse to all of this stuff. No, these do not cancel. This was applying directly to a sine. This, we have a 7 here. It's going to be more complex than that. And so this is as far as we can get. However, we do know the sine of 30, so we can simplify that. So x is going to equal whatever the sine inverse of whatever this is. Well, sine of 30, we know. We can go back to our reference triangle here. Here's 30. Sine, again, is opposite over hypotenuse. So here's the opposite side, a half. And we're dividing it by our hypotenuse. And thank goodness for the number 1. Dividing by 1 is easy. A half divided by 1 is just half, just like any number divided by 1 is itself. So sine of 30 is a half. Cool. So I can simplify some more and get x equals the sine inverse of all this stuff. 7 times a half is 7 over 2. And that's still all going to be over 4. Well, you know that when we have double division like this, we can, instead of dividing 7 halves by 4, we can multiply 7 halves by the reciprocal of 4. So we're going to get x equals the sine inverse of 7 halves times the reciprocal of 4. And of course, the reciprocal of 4 is 1/4. So what is this going to become? Well, it's going to be 7 over 8. So I'm going to scribble this out because I'm running out of room. And I'm going to write the simplification of 7 halves times 1/4. And it is 7/8. So our answer is going to be x equals sine inverse of 7/8. And if you wanted to know what that was, you could pull out a calculator and figure it out. And it would give you a number for x. It would probably be a decimal. This is an acceptable answer. So that degree right there is going to be sine inverse of 7 over 8. Whatever that is in your calculator, that's the degree measure there. So that's how you do some law of sines problems. I showed you one where the side was missing, and we were given the two angles. And I paired them up. We solved for that side, and we got something kind of nasty. Again, sometimes these numbers can go away nicely. If you know both of these sine values, you can cancel some stuff out pretty nicely usually. And I showed you an example where we're looking for the missing angle. So you can use it as well for that, where x is now inside the sine, because it's an angle, and we solve. So that is law of sines, a basic breakdown. Best of luck on your homework.